Compound inequalities. That is when you have two inequalities that are drawn on one graph. So that generally means that they're going to share a graph. There's two types. Type 1, outward graph, sometimes called an OR graph. That means that your inequalities will face outward or away from each other, and there will be no overlap. When you hear the word OR, it always means that you can either have one Oreo or you can have a piece of cheesecake, but you cannot have both. So we are not going to have any overlap. The second type is type 1. That's an inward graph. And that generally means you'll have two inequalities facing inward. They're just sometimes called an AND graph. And that means that there's going to be some overlap. And that's where you get the AND from. So you can have your Oreo and your cheesecake if you want now. So let's try these types of problems. First, an OR problem. And here's the giveaway for an OR problem. It's gonna say OR. So, our problem is negative 3x is less than or equal to negative 9. Or, and that's the dead giveaway, 5 plus x is less than 6. Now you guessed it. We have inequality A and inequality B. So I'm going to draw a line because I want to know that I have to work one problem with one answer and another problem with one answer. But I'm also going to do another piece of prep work. I'm going to draw my number line so I know I only have one to use. Now let's solve. We're going to divide by negative 3 on both sides so that we can isolate our x. Those cancel out and we are left with x. And on this side, negative 9 divided by negative 3 is positive 3. But as you can see, we divided by a negative, so we want to flip our inequality sign. This is one answer I want to see on your test with a box around it. Now shift gears over here. We want to isolate x. So let's do our highlighting trick, because he's not going anywhere. But our 5 needs to go hang out with our 6 on the other side of the inequality sign. If we have a positive 5, we want to get it back to 0 by subtracting it. So that cancels out and we're left with x is less than 1. So I want another box on this side. Those are my first two sets of answers to work with. Okay, so now we're going to graph. Let's make our intervals on our number line so we know where we're graphing. We have x is greater than or equal to 3. So I'm going to color in my circle over 3 as it's a solution, a possible solution, and I'm going to point my arrow to the right because my points both face right. Then I'm going to pretend this one's not even here. And I'm going to look at x is less than 1 and I'm going to go, all right, I have less than, which means that it can't be 1. So I have an open circle. And then I have to draw it left because my less than sign points to the left and so does my arrow. So that's step 2. My third step is to write interval notation. As you know, I draw my pencil from left to right on my graph, and I read it left to right. So we know negative infinity is over here, and infinity and beyond is to the right. So I'm coming from negative infinity, and I stop at 1. But 1 is not a possible solution because it's only anything less than 1. So I use a rounded bracket. I write or you can use a union symbol. It's up to you. And then I continue. So I come in from the left, stop at 1, pick up my pencil, move it over to 3, and that's where I start again. So 3 is included as a solution, therefore I'm using a regular bracket, comma, all the way to infinity. Any solution that's greater than or equal to 3 is a solution. So this is just a fancy way of writing the graph. Please, please, please read your graph from left to right using your finger and write your interval notation as you do so. This is an outward graph. They're facing outward. It says or, so they don't overlap, and you're all set. Let's try an and problem.